said, Alex. Let me move the windows around. Okay.
I can see your screen. Do you want to go full screen?
Yep, I will do. So with that, I will talk today about IBM Cloud Code Engine. So my name is Jeremias, and I'm from the IBM Cloud. I'm senior technical staff member. Just a few words about myself. I spent almost 10 years in serverless computing now. In 2016, it was my first product where I worked with. It was the initial committer of Apache OpenWhisk, for those who know it and maybe worked with it. In 2016 to 2020, we built IBM Cloud Functions in the IBM Cloud, which was based on Apache OpenWhisk. And in 2020, we saw, and this is the first evolution step we did, we noticed that the functions as a service, as it was designed in these early days, had limitations like the size of the functions, and also the duration of how long it could run, and also the workloads which are applicable for it. And that's why we invented then and adopted Knative and launched with Google together Knative at the end and run it as an IBM Cloud Functions in the IBM Cloud Code Engine in the cloud. I will talk a little bit about the architecture. So I'm the lead architect for IBM Cloud Code Engine since then. And nowadays, we are doing a second evolutionary step, which is going towards large-scale compute-intensive workloads. And we are currently focusing on a new concept called serverless fleets, which I will touch at the end of my talk. Okay, so with that, so what does serverless mean for us in IBM Cloud? And that didn't change really since the beginning. We want to run any code easily at scale. Right? So what does it mean? We want to have users focusing on their business logic rather than dealing with infrastructure, setting up complex networks, and so forth. We just want to focus them on the code. In functions, it was very obvious just looking at function snippets, right, and scale them out. So go live in seconds. What we mean with that? Then we easily scale from 0 to whatever you want in a rapid way, and also even down to scale to 0. That is what serverless really means for us, right? At the end, only if you run workload, you charge, you pay for it, and you only pay for really what you use. And if you don't have anything running, you're not paying for it. And this really didn't change. But what changed over the course of the years was the workload applicable for it. And now we are getting into a new area with AI and agents and MCP servers, right? And model training, model fine-tuning, inferencing, batch inferencing, interactive inferencing. So all of these workloads may also now have influence of how we evolutionize the serverless computing platforms. And that's what we do within IBM Cloud since 10 years now. So what are the personas we know? And this may also change with AI. And we may get another persona in here. But at the moment, we're sticking with those 4. So we do have users who are running containers on, they are Kubernetes developers running on containers, but they don't want to deal with Kubernetes clusters, setting up ingress, egress, all these deployment YAML stuff and scaling themselves. No, they just have a container and want to run the container in the cloud. AWS Fargate is playing a role here. For example, right? Like Code Engine. And the other persona is just a coder. You may know Cloud Foundry. A person, a developer who is just source code, he doesn't even know how to build a container, knows about Kubernetes. He just has a source code, a microservice, a REST API, and just want to run it from source code. So that is the persona we are addressing as well. Then you have the classical serverless function developer. This is from the early times from AWS Lambda. Someone who has a function snippet, want to have glue code between calling 2 services, like implementing a chatbot which is receiving the chat, transforming the content, calling another service, getting the response and returning back, transforming the results and returning back to the user. And then, so this is a typical functions user, which we know from 2015, 16. And then we do have batch developers, and that's what we focus now, which gets a new sense also in the AI, with the AI technologies which are coming up, where we have a need for very compute-intensive workloads. It's even HPC-like of workloads, which we are addressing with the batch developers and also with a new concept we are introducing called serverless fleets. Okay, so looking at the competition landscape, Code Engine is playing around a role here as a unified platform, where you have in AWS, for example, Fargate or App Runner, Elastic Beanstalk and App Runner, AWS Batch, AWS Lambda. You need to go through several services. In Code Engine, it's just in one unified platform, as you will see in a minute. So that is a key strength for us. You just go at one place and can manage all of your workloads. How did we build it architecturally? That's what it is. As you can see, Code Engine in the IBM Cloud today, we are, of course, based on physical machines and virtual machines. So for those who don't know, they are really servers, and it's us, the Code Engine team, which are responsible to manage them. We want to hide all of the complexity from the user. So you can see on the left-hand side, the user has more control the lower he goes on the stack, but we want to focus on speed and ease of use, okay? And what we build is a gigantic Kubernetes clusters. Behind the scenes, there are many, multiple of those Kubernetes clusters where we are placing the workload efficiently. We are using open source technologies like Kubernetes, like Knative and Istio, like Tecton, Chipwright, and the build packs. We also use some artifacts we use for IBM Cloud Functions, which are part of the Apache OpenWhisk, which is also used still to ensure very fast scale-up times for functions, for example. So the user, developer, is just going to Code Engine, dealing with a function, with an application, with a batch or a container, can run it, and we are managing the whole infrastructure for them. Okay, so let's do a quick demo. Ich kann jetzt nicht. Just a second. Okay, so sorry, that was my daughter just interrupting. So let me do a quick demo. So if you go to IBM Cloud, let me log in. I'd like to show how easy it is to run a container in the cloud. Let me log in. Here we go. Security goes first. So if you don't know how to find us, you just type in IBM Cloud Code Engine, press enter, and you just use the first link or the second link to directly jump in. So what do you need an IBM Cloud account. So it's running an IBM Cloud only, right? It's a managed service. It's not running on-prem. You cannot install it anywhere. It's only running an IBM Cloud. I'm logged in with my own account, and now I'd like to make a challenge. So please count the number of clicks I'm actually doing in order to launch something in the cloud in a serverless way. So first thing is I'm going to containers. So we are in the containers pillar. I'm going to serverless projects. Doing get started, start creating. It basically asks me where I want to deploy my workload. We have presence in all the major MCRs. And next, ask me which type of workload I want to run. Do I want to run an application? An application is an HTTP response to an HTTP request. So it's a HTTP request response type of workload, typically microservice, a web application. Do I want to run a job? So a batch job, which runs to completion, processing some data, or a function. So let me just simply run an application. I'm giving the application a name. So let's do a give it a name. You can select whether you have your own container image. If you have one, you can select it. It can be on Docker Hub. It can be on our IBM Cloud Container Registry. You will need just to provide the registry secret to get to it. Or if you just have source code, you're pointing it to the GitHub repository. So let's say if you have a Python app in GitHub, you just point us to the repository and we know how to build the container image out of it. And we're using Shipwright and Tecton to build the image for you and push it then to the container registry. So as you can notice, I didn't change anything. I'm using the Hello World default image we have. And then you can specify the scaling of the application. So let's say I'd like to have 1 CPU and 4 GB. You can select many different ratios. And here's a notice from what we did in the 10 years ago. You only had a selection of memory, right? 4 GB of memory. It was even a large function already at that point in time. So nowadays we are also having CPU ratios because we are seeing an increased demand for large compute intensive workloads and needs a lot of CPUs and even GPUs as it comes up. And that's what we are addressing with serverless fleets and memory as well. So you can select certain combinations here. And then you can specify the scaling, whether you want to have 0 instances. This is actually the scale to 0. If you always want to have 1 instance running because you need a really low latency and need to have something always up and running, you can say, I'd like to have 110 instances running. It's, from our perspective and our definition, it's still serverless, even there is something running 24/7 then, because you still have the easiness, the automatic scale, and you have also the pay by use, right? You can easily change the parameter, it scales natively. And if you can accept it from a workload perspective, you would say 0 and it would scale down to 0 if there is no HTTP request coming in. And what's behind an application, it's basically Knative on Kubernetes, which is doing the scaling for us. Okay, that's it, right? I say I'd like to have this application publicly in the internet. I can also hide it, but let's say I'd like to have it public. And so I can create the application. And that was basically my 3rd click. So it was just 3 clicks getting through it and deploying the application. Now it's running in the cloud. I could, while it is scaling up the first instance, so you can see the instance is up and running. I could test the application, sending a request. And you see there's a response. So it just took a few seconds for the instance to come up and respond to the HTTP request. Now I can send many HTTP requests. At some point, based on the scaling behavior, it may scale out to multiple instances. Okay? And if I share the application URL over here, let me share that maybe in the, or maybe Alex, I just ping it to you internally and you may just share it. Or I can have, yeah, if you could share it maybe in the chat here.
Yes.
So others could try it out. So this application is now in the internet, right? We are doing all the networking for you. We put let me show that to you maybe. So you can see this is a secured endpoint. We are creating a certificate, an endpoint. We are having the load balancer set up, the ingress set up, and made that endpoint publicly available just with a few clicks. Okay, that's what IBM Cloud Code Engine doing. So now maybe since we have all the lot of participants here, attendees here with a scientific background, I'd like to also quickly touch on jobs because we see an increased demand on the use of jobs for AI-related workloads. Let's say also pre-processing. We have one large customer doing pre-processing for the model training by parsing documents like PDFs and other formats. So let's go back to my project and talk a little bit about jobs. And by the way, the application, if no one now hits the URL, at some point it will scale down to 0, right? Because I kept the 0 as the min scale parameter. So now next is, let me create a job. So let me go back to maybe get started. Or let me create a job here. Oh, here. Let me create a job. A job behaves very similar, so I give it a name. Let's keep the default. I'm also using the base image. The only thing which changes is how I scale the job. The job is not receiving HTTP requests. The job is something where I say how many instances I want to kick off. So let's say I want to run 10 instances. What that means is we will start 10 instances, and each instance will get an identifier from 0 to 9. And so each index knows, okay, I'm number, let's say 5. And based on this index, the job is responsible to grab the data, do the processing, and store the result. And so we have users starting that in a free tier, just running a cron job every hour for the few instances. We have also customers running this with 400 instances in parallel for months, and doing heavy processing. So you can also configure the scaling parameter, and let's say I just created with 10 instances. I'm creating the job. It's being created. It's not running yet, so it's not charging you anything. It's just the job definition I just created. So now I can submit the job and override the parameter. So let's keep the 10 in here for simplicity. Kick it off. And you now see you have a kind of a batch job running with 10 instances. Code Engine will make sure we are scaling the container, we are finding the infrastructure, deploying it. And then once it's succeeded, the developer can fetch the result and move on or rerun the job, right? We also we retry the job if something fails. We make it easy to resubmit the job on the larger set or on the smaller set or just on the failed instances, for example. Okay, so this is what we have in one unified platform, but we notice that is not enough. And so maybe let me jump back to the slides and introduce something which we learned based on this whole AI hype and AI revolution which is going on. Maybe before we go there, one word about pricing. This is all priced paid by use on a 100 millisecond basis. We do have a huge free tier, especially for those who are on a university and doing scientific processing. It is possible to do quite a bit in the free tier. And charging is really as you scale up. It's what we charge on a per use basis, but the free tier is also already significant. Okay, and as you have seen, we have adds, jobs, and functions, and there was also this white space here on the chart, and that's what we wanted to fill, and that's what we also learned from our customers, asking for more compute-intensive workloads to run in a serverless fashion. And that's what we address with, we call it serverless fleets. It's something which I don't think anyone else has. It is currently under development. It will come out later this year in the next quarters. We will roll it out in stages. If someone is really interested to try it out, feel free to reach out, and we will also make a tutorial public available soon. We are addressing large-scale compute-intensive workload like Monte Carlo simulation, financial risk modeling, chemical molecules calculation. I saw an example from EMBL later. There's a talk, nice fit here maybe to think about if you could benefit from it. AI training, fine-tuning, inferencing, of course, right? On serverless GPUs. So serverless fleets will support serverless GPUs. So this is what I say. We came from functions. We are moving to, we moved to jobs and apps, and now we are going to fleets, which is, I think, addressing a much broader HPC compute-intensive kind of workload, which was not possible in the architecture and with the capabilities we had so far. I'm jumping over in the interest of time on the main differences, but how it works is we do have now very dynamic queuing in place. So if you look at other serverless offerings, there is not really a queue in place. But here with fleets, we are introducing a kind of a queue. So if you have a task, let's say a famous example, let's pick something fancy with AI, is 19 million JSON files from a chemical or pharmaceutical company. 19 million files, and using a large language model to extract information out of it based on prompts. So this is a very nice use case. So think about it. It cannot run locally on your laptop, right? It will just burn for months. That's why Fleets is a good fit. You just hand over 19 million tasks, which is your Python code with 19 million JSON files on a cloud object storage to us. Code Engine will scale up the GPUs that you can specify which machine flavor you want. If you want to have a GPU, we will scale up the GPU, but it also works with regular CPUs, of course. We will scale up the virtual machines for you when we start charging you. We will pull the code on all of the workers, so there may be hundreds of workers coming up. Each worker will autonomously pull from the queue, process, and apply the code you provided on the task until all tasks are completed and the queue is empty. When the queue is empty, we will and a worker will not find anything in the queue anymore and will autonomously shut down, and the Code Engine will remove the the worker, deprovision the worker when we also, and then it's when we also stop charging the customer. So really pay by use in a serverless way, large scale run to completion workloads. And we do have a couple of use cases here, also not industry specific, across industry, and all the other serverless attributes apply. Simple, no deal with infrastructure. That is a promise we always want to keep. Okay, so maybe let's do a very quick demo that you get an idea of how it works, and then I have, I think, 10 minutes. I have a hard stop, so 10 minutes for questions. Let me do a quick demo on this. Is it just CLI based at this point? And the demo is about doing Monte Carlo simulation. So think about, you want to simulate stock tickers. And you have a little bit of Python code, like this simple Python method here, which we want to run on a stock ticker, right? It downloads the historical data and then doing about 1 million simulations here. What you need to define a task and submit the task. A task is now apply that Python code, the simulation on each of the stock tickers you have. In this case, I just have 24 stock tickers. You can also think about hundreds of thousands of stock tickers or what else, right? It also gives other arguments. So you give us a list of commands and arguments you want to process in combination with a container image. That's what we receive as an input. So let me do that on the terminal. So let me go into the tutorial simulation. You can see here, I have my commands JSON. This is running. This is here. On the upper right corner, I'm watching my fleet workers. You can see there is no fleet worker. Now here I can watch my tickers. There is no result for my tickers, so there is nothing yet. So let me run a fleet to run these 24 tasks. So what I do is just calling run to launch the fleet. So the fleet will get a name, it will use an image. The image is what I can build with Code Engine, like I showed you earlier with a GitHub repository. We are saying we want to use the commands, the tasks from the commands JSON. We will have different methods to submit tasks. You can see how many CPU, or can define how many CPU and memory you want to have per task. So each task needs 1 CPU and 8 GB. And you want to have, in this case, a max scale of 24. So we want to run all 24 in parallel. So on the right side, you see now machines are coming up. It selected an MX2 4x32 machine profile. Let me just do a quick get. We look at the fleet details. So it took a machine with 4 CPUs. We want to run 24 tasks. We do have 4 tasks because we said 1 CPU per worker. Per task, it now can run 4 tasks in parallel on a single worker. That's why we need 6 workers. So that's why the system came up to the conclusion to use 6 workers. That's what we have, what you see being deployed here. So now there is a task queue, and I might be too slow to show you the task queue. Let me hurry up to show you the task list. And you can see on the right-hand side, we also already see some results coming up. And you can see all the 24 already succeeded. So if you have now 19 million, you can see how the queue is slowly training off, right? Here you can see that the result, it's already done. You have the 24 results, and the machines will now stop and will be removed. So this is something which is, I would call it basically very powerful to do compute intensive workload in a serverless way, right? It's more than just a function. It's much bigger, and it can run GPUs and CPUs, whatever machine profile you need for this large-scale computations. So now there are challenges, especially with AI and models. So a lot of those challenges were already mentioned in the poll, so I really liked it. That's why I don't want to repeat it. And at that point, I'm done with the demo and opening it for questions. I do have 10 minutes. So if there are any questions, feel free to ask them.
Yeah, so feel free to unmute yourself if you have a question. And maybe I will start with the first one. So when users are using it and they want to run those large computations, do they set like a budget? Can they like monitor that not by mistake it suddenly starts 1 million GPUs and then get $1 million bill?
Yeah, that's excellent. We are always getting this question. So this is good, because when we get the question, you already imagine how this works at large scale. So yes, you define basically with the max scale parameter how many instances you want to run at a point in time. Of course, we will have quotas which will protect you if something goes wrong, but just from a scaling perspective, you could run in micro batches. So you could say in my commands JSON, I just put 1 million out of the 19 million, or just 1,000 at the beginning. And you say I'd like to only run 1 GPU. So max scale of 1 and 1 GPU requirement in here, for example. And then we would just scale up 1 GPU running through all the 1,000 tasks, right? Once you're feeling confident, that's what our users are doing, then they play around with the parameter, maybe running 2 in parallel, maybe running 4, maybe 10. And that's also how, that's basically how our users are basically starting low, paying only, experimenting, and then scaling out once they feel confident. Yeah. But yes, you're right. At the end, so maybe one point. If you have 90 million JSON files, and each JSON file takes a minute, you have 90 million minutes to process. And if you need a GPU for one task, then it is what it is, and it costs what it costs, right? To get these computations done. The only thing you can control with this parameter is how fast you can get you will get the result. So the costs are always the same. Of course, you have a little bit of overhead if you need to pull the image more often and stuff, but let's ignore that. At the end, the costs are the same for the processing. It's just the throughput that you can control. Because this is always also the second question which comes after. Just taking that. Okay, anything else?
Another question, Alec, if I can add here.
Yeah, go ahead.
Yeah, no, it's very exciting because Google, with Google Cloud Run, they are also offering you GPUs now. And it's very interesting because we always try to compare the services. And the nice thing is that we know that, for example, in the managed version, I mean, CodeEngine or Fargate enable direct communication between the containers, whereas Google Cloud Run, they cannot do that. So it's more that, for example, Dask, we will see later a presentation where you can deploy Dask because you have direct communication between the containers in CodeEngine or in Fargate, but not in Google Cloud Run because they don't enable that. So I'm not sure if you can answer here, if you can distinguish yourself from Google Cloud Run, but also what kind of workloads. I mean, this is now mainly aimed for inference workloads, or is it possible, did you try with training workloads that require communication between the different containers, or what kind of workloads are you targeting here?
Yeah, so this one, that's a good one. Do I have the slide in here? No, unfortunately not. Yeah, so we are addressing basically run to completion workloads, batch kind of workloads, meaning non-interactive workloads with fleets. And with the serverless GPUs at this point in time. So we see a bigger bang for the buck or more demand in run to completion batch workloads with large scale compute. Let's say, like I said, a lot of data in a cloud object storage, and you need a large language model to do inferencing on it. Or you have like a lot of PDFs. You want to pass the PDF with Stockling in order to extract information out of the PDF, which you can then use to fine-tune your model. So pre-processing for AI workload, for example. So those kind of workloads, but the interactive inferencing is something which we see more in an opinionated service, which is then also charging for tokens, number of tokens being processed, right? Which is like ChatGPT or the WOSCx runtime or Perplexity, where you just type in your question, you're getting a response for, and you can maybe select the model you want to use, you're getting a response, and you're charged on the tokens that are being produced. So this is not what we are addressing at this point here. It's more general compute, but we see a big demand around AI, using AI, or in preparation or in post-processing of AI.
Okay.
I have a question.
Mhm.
With this new fleet, you can choose the type of GPU.
Yes, you can choose the type of GPU. Yes.
Okay.
So it's yeah, you can basically, it's agnostic to the machine profile. In IBM Cloud, we have the Teslas, the V1, the V100, the L4, L40s, the H100, H200. We will get Gaudis and AMDs, so a wide variety of GPUs available. Or
Because I saw the command and doesn't have any flag of the GPU type or something like that.
Yeah, that's a good point. I hide it here because I let the system configure it, but you do have a worker profile flag which you could pass in the CLI, and then you can specify the exact machine profile you want to have.
Okay, thank you.
I have a question, maybe. How would you envision, or how does it currently work? Like you run, or if I would run, like say, some LLM training or any machine learning training on multiple nodes, and one machine fails, would you be able to automatically, or would you be able to recover from that, or would the whole fleet stop? And I would need to reinitiate the training.
Yeah, good question. So we are thinking about it on different layers. So we will retry tasks. So if a container fails, we will retry the container of the task 3 times. You can configure it. And then if a machine crashes, we will detect that and replace it with another machine and give it another machine a try. We'll also think about that across availability zones and make sure, for example, if there's a zone outage, which happens in cloud, that we are taking GPUs in different zones to get to the same max scale you have configured. Those kind of recovery mechanisms are basically built in. Yes.
Okay, thanks.
And then also what we will think of if you now have a fleet which runs, let's say, 1,000 tasks and 200 failed or 100 failed or 50 failed, that you can identify and easily run another fleet on these failed ones, right? Because you may have a code bug, you are running the exception because of whatever, and therefore you need to go to do a code fix. You do the code fix and run another fleet, but just on the failed ones which were not covered with your current code, for example.
Okay. Oh,
Yeah.
that's nice.
Yep. All right.
Okay, very good. If there are any follow-up questions, you can also ask them in Discord channel, and I will pass them to Jeremias.
Yeah. Thank you, and I looked through the other talks, looked at the slides, so very impressive. Have a lot of fun, and in case you want to reach out, feel free to reach out. I'm also on LinkedIn. Please feel free to connect to me. With that, I wish you a good afternoon or morning, wherever you are, and have fun with the workshop.
Thank you.